Hi, Coder. We're going to whiteboard or scratch paper a little bit here. That is really the way to get going, I feel, for coding. Really, it's so helpful. We're going to look at functional programming and how it applies to the binary search tree. So first, let's take a look at the binary search tree a little bit without functions. So here's a simple tree. We have contact, objects, and a name and a phone number we could see there. And we could see that small goes left, large goes right. We could see that Asha was placed left and Zoe was placed to the right. We could do a comparison for a contact easily, right? We could easily compare those two names, or we could do a tree, we could compare numbers. We could have another tree with employee. In this case, we would compare IDs, right? Smaller ID left, larger ID right. We could do that. We could code that pretty easily. Without that comparison would be easy, right? ID is less than, the ID here is less than, compare the two IDs, and which one is less goes here. We're running into a little bit of a problem you can see right away though, right? We'd have to code a separate tree for every object we have, and it's even worse than that. If we wanted to sort contacts by name, we'd have one tree sorting like we talked about, and we have another tree we'd have to code sorting for phone number. Well, that's completely unrealistic and crazy, right? I mean, coding for one specific case would be, it'd be job security, but nobody would have us do that, right? Us coders want to keep it somewhat general, so that's what we strive to do. And this is what we really want, right? We don't want to limit ourselves to contacts or limit ourselves to employees. We want to have data in our tree, any kind of data, right? And if it's less, it goes over here. If it's greater, it goes over there. So how do we do that though? Because we've now lost track. We don't know if it's a name or a phone number or an ID. We don't know. How do we do that? That's where functions come into play, actually. We have a function on hand, and we could call it whatever, but if we call it a sort function, and that right here, let's say, data 2 is coming into the tree to be added to the tree, we would simply compare, simply send to that sort function data 2 and data 1, and it would give us a result. If that result was less than 0, we'd add it left. Otherwise, we'd add it right. So very nice and simple, right? This would handle this case. It would handle a name case, that case, whatever, because it would be our object user. We're spoiling our object user. Would be they would be able to do it however they wanted to do it by passing us a sort function. And we don't have to worry what's inside the sort function. We just call it, right? Just like any we just call that function with those parameters and get the result. And we go left or right. So let's take a look here. Again, it's spoiling our user here a little bit on why we actually have two functions. So in the case we just talked about, that's adding a new contact, right? And in this case, we would have actually data coming into our tree, and we would add that. A new employee would come in. If this employee came in to the tree initially, we'd add it, right? Well, we don't want to make our object user, our client, search for objects. That would be weird, right? They'd have to construct the whole object they're searching for. Well, if they already had the object in hand, why would they search, right? They'd rather search for just the key, right? Like a phone number here or a name. They want to search for a key, and that's why we have the other function to come into play there. So that's really what these functions, that's the purpose, the drive for them. So it's the same thing though with the add function on search. Same thing, that key comes in, we again just apply our function. We don't care what's inside it. We don't care how our client's coded it. We just call it. We just trust it, object trust. We pass the key in and we pass our data in, and it's going to tell us, that function is going to give us the exact result we want. It's going to give us an answer that's going to be less than 0, then we'll continue our search left. Otherwise, we search to the right. So that's kind of an overview. It's really, I like to do this without Java, especially Java is verbose and makes things complex. So I find it much simpler to do it without Java, things without Java first. Then we just have to figure out how to work these functions in Java. And really how that's done, and we'll do another video on that in a second, but how that's done is like this, except we just throw the word compare or apply in depending on the function type, but that's all that is. Just a regular call, like a method call. They're objects, functions are objects. So that's it on functions with language independent, whiteboard, sketch paper style. Talk to you soon.